Hello everyone, my name is Matimoyo and I'm going to be presenting on the Koch Snowflake. Now, Koch Snowflake is a fractal. What is a fractal? A fractal is a shape that demonstrates infinite levels of self-similarity, or has the potential to. Here's an example of self-similarity in this plant to the bottom. The whole plant is shaped in a sort of triangle shape. Then if you go down a level, the offshoot of the stem also grows plants in a triangle shape, and it's not as really easy to see, but those that offshoots from there also grow in a triangle shape. And this is an example of self-similarity, which is parts that look alike on different levels or different sizes of the same thing. And that is one element of fractal. The other element is that it has infinite iterations, which means that you could have an infinite number of these little offshoots, and it will go forever and ever, increasingly self-similar as time goes on. What is the Koch curve? Now, the Koch curve is a type of fractal that demonstrates the quality of having an infinite area in a finite space. In a finite perimeter. As you can see, this is the first step, otherwise known as the seed shape. It's a sort of triangle and two lines to the side. Then, with the following process of self-similarity, we shrink the seed shape and then put them on the sides of the original. So imagine taking this whole thing, shrinking it, and then putting it on this side. That's how we get this and this and this. And then we shrink the seed shape again and we make it even smaller and post it on the sides of the sides. So it gets increasingly self-similar, and technically it could have infinite iterations. Now, the Koch snowflake is a variation of the Koch curve. It also can have infinitesimally small iterations. That means infinitely small. And it can also show self-similarity on different levels. This is my drawing of the Koch snowflake. As you can see, this is the first iteration is the triangle. Second iteration is the pieces jutting out the side. Third iteration is those jutting out from those from the sides. So each iteration has its own area and perimeter. The area of iteration 1 is 15.75 square inches. And the perimeter is 18 inches. That is the basic triangle. The area of the second iteration, which is when you add the pieces on the sides, the area of the third is 24.75 inches squared, and it has a perimeter of 36 inches. Now, like the Koch curve, the Koch snowflake has a special quality. It can have an infinite area in a finite amount of space. So basically, when you're adding the triangles onto the sides in the previous one, you're basically limited to a certain amount of paper. In this case, my sheet of paper. So while you're adding triangles onto the side, you basically are creating an infinitely long line of triangles that will circle around here. And that's how you would have infinite area. But you're in a finite perimeter because you're limited to this amount of space. I hope you guys enjoyed. If you have any questions, email me at isstudentadai@gmail.com. Thank you.